Thank you all for joining us on this episode of Mac Panel Test Connect, where not only do we connect you with high-performance connectors, but also partners to help you dominate any testing application. So here with me today, I have Noman with Pickering Interfaces and Taylor, one of my colleagues at Mac Panel, who's a engineer. Noman, would you like to go ahead and give us a short introduction of who you are?
Sure. My name is Noman Hussain. I am VP at Pickering Interfaces, responsible for software and strategic business development.
That's awesome. That's awesome. Well, look, we really appreciate you coming out and have really enjoyed working with you, and then also with Pickering as a whole over the last few years. So it's been great.
It's been a great partnership between Mac Panel and Pickering, and we really appreciate what you guys are doing in the industry and for us.
For sure. Thank you so much, Noman. And Taylor, would you like to go ahead and just give us a quick rundown of what you're doing with Mac?
Yeah. My name is Taylor Shaw, electrical engineer at Mac Panel. This is the first job out of college. I've been there for just over 3 years now. Before that, I'd had a few internships at a couple different companies. One was an LED lighting manufacturer in Northern Illinois. The other one was a company doing something with power simulation.
The reason I have these really smart guys near me talking about, on this podcast is to talk about BMS testing. The title of the podcast is The Evolution of BMS Testers. And so what BMS is the battery management system. It basically is what controls, a battery within the EV market. So the EV being electrified vehicles. But before we get into all of that, I was on the way up here this morning, I was thinking, we had a conversation last night, and I think, Noman, you had mentioned that you had imported a Camaro, because you're obviously from the UK somewhere.
Yes, that's correct. So I live in Colchester, nearby London in UK, right. And I can call myself a petrol head, maybe, because I imported a Camaro. Mm-hmm. It was a yellow Camaro as well.
Did it
Bumblebee.
Have the black stripes?
That's correct.
My God.
It has to be a yellow Camaro.
That's the one I've always wanted.
He took it from you.
Yeah. You imported mine out from underneath me and brought it into the UK.
Oh, believe me, it took forever to get there. But once I got it, it was worth it for the novelty factor.
Were you the only guy in the UK with a Bumblebee Camaro?
I was the only guy in Colchester.
Okay.
But there are a few other fanatics.
So you were somebody.
Yeah, that is correct.
What was your first car?
My first car was a Suzuki Swift. It's I'm a big fan of Japanese cars. Okay. So I had a Suzuki, a Honda, a Toyota, mm-hmm. a Mazda, mm-hmm. before I moved to American cars. Mm-hmm. Then I had a Ford Mustang in UK, where the steering was on the correct side, as I like to call it.
Oh, really?
There's a right side and the wrong side.
Yeah.
Rather than the right and the left. Then
what year was the Suzuki Swift?
Oh, that was from my first paycheck when I first started at Pickering in 2010.
Really? So it was like a 2010?
2010. It was the very first car. It was one of those cars that you buy in so you can look at other cars.
Wow.
So it's been a smooth transition between different cars.
You went from Suzuki Swift to Camaro,
Yes.
And then and we'll get to what you're driving now in a minute, but I wanted to touch base on what was your first car?
A Mazda Protege that took on water when it rained and then froze in the winter because we were in Northern Illinois.
We're talking about EV vehicles or electrified vehicles.
I was working on a water powered car.
Yeah, that's what you were working on. What is that, a hydro cell car?
Yeah.
You were halfway there. You were taking on the water.
I had the water.
Didn't know what to do with it after that though. That's funny. And so mine was a 1990. I think it was a 1992 Nissan NX 2000, and it was small. and it had the T-tops on it, and I thought I was the coolest dude. I was 18 years old, 19 years old. I thought I was the coolest dude driving around my small town with T-tops off. Little did I know I looked like a dork because it was a Nissan.
Yeah.
And it wasn't like the Z series, it wasn't.
Right.
It was an NX, so it was kind of the 1, 2, or 3 below the Z series. But it was a fun car to drive for the whole month I had it before I wrecked it.
Oh, geez.
But back then I didn't really keep an eye on gas mileage. But now, as
were you paying for your own gas?
I was.
Yeah.
Yeah.
I was. I was working a job for my dad doing like landscaping, and it's like, all right, you can have a car, you got to pay for the gas.
See, back in '98, I remember paying 87 cents for a gallon of gas. And I mean that's what we were paying.
Yeah.
So it wasn't that big of a thing, but as gas prices become, and it's not that they become more expensive, they just become more volatile.
Yeah.
Well, I think they've always been volatile, but
we've seen a few big spikes in the past decade.
What's the price of gas per gallon in US at the moment?
It got up to like, what was it, 485?
It got average got much higher than that. I think. I think it hit 5.
If I convert that
to
UK, it's it'll be more than $10.
Yeah.
For a gallon of gas.
Yeah.
Yeah.
So because we are paying about $1.92 a liter. Because I drive electric car. Don't ask me how I know that, but it's just one of those things I always keep an eye on.
Yeah.
So I mean, we've talked about all these cars that each of us have had, and in 2006, 2007, along comes this guy that nobody really has heard of, or there's quite a few people that have heard of him, but just not in the auto industry, right? And he comes out with this thing called a Tesla, right? And it's an electrified vehicle, and Noman was blown away, and so he goes out and he buys a Tesla, and so that's what you drive now.
I did. So I went from a Camaro to a Tesla, which going from a really loud and exciting car to a car which is exciting in terms of technology,
right?
And what it brings in a very different way. You don't hear much of the car, so.
Right.
If you're driving a petrol car, you put your foot down, you go,
Yeah.
If you're driving a Tesla, you put your foot down, you go.
That's funny. So I said 2006, 2007. Here comes Elon and Tesla. And one thing you brought up last night, and then you sent us an email kind of showing, is that electric vehicles didn't just come out.
No.
They came out when?
The first electric automotive sort of locomotive that was created was back in 1830. So it is at least in 1830. So it is at least a couple of decades ago.
Centuries
ago. Sorry, not decades.
No, you're fine.
Yeah.
I mean that blows my mind that around about 200 years ago, we were investing in research, right? Obviously, or somebody was on electrified vehicles, right? And then they just kind of shoved it off to the side and said, "No, we'll do petrol."
I think it was before the Second World War where people looked at the fossil fuel as a replacement. But before that, I think it was more towards electric cars, basically people using batteries to sort of drive. But and as Taylor mentioned earlier, that the batteries weren't rechargeable. So.
Yeah.
Oh yeah, during our conversation this morning, that was one thing that Taylor did bring up, was that I guess during you were reading this article, and what was that? So it's
I can't remember the composition of the battery, but it was not a rechargeable battery.
Okay.
They had to replace it. But I can't remember exactly when. I think it was right around World War II where they were able to develop a rechargeable battery.
Interesting.
And it was about at the time of World War II that the difference, or I'm going to start saying petrol. Gas powered cars really took off away from the EV cars, because you can go through the history of EV vehicles, and it's pretty prevalent. You'll see them at the World Fair. The son, or I think it was the son or the father of whoever started Porsche, created a electric vehicle.
Really?
Even there were certain motorsports that were exclusively electric vehicles. So it was kind of always there. World War II, right after that, that's when the gas-powered car kind of took off. But I think we're seeing a resurgence now with Tesla coming in, making it more available to a modern consumer in a form factor that's much more functional and practical.
I think Tesla's claim to fame in that respect is they made electric cars sexy. They made them more appealing to the mass audience.
Yeah.
They made those cars more appealing in terms of when you go and look at different cars and different options, you will go, yeah, I would like to have a Tesla.
Yeah, it looks nice.
It does look nice.
I was going through, it was showing some of the old ones. There's this one electric car. It looks like a wedge of cheese. It's like it's a triangle.
Okay, that's the other. Sorry, that's the other thing that we kind of talked about last night that just kind of made me kind of remember it, which was, electrified vehicles don't have to be cars, right? It can be helicopters or drones that are like man-powered, like you literally get in there and it takes you to, and then you mentioned this. Was it you? You mentioned this morning about the rovers.
Yeah, rovers. I mean, it's something that's like always been there, but
the Mars rovers.
Mars rover, the rover that they used in the Apollo missions that went off from where they actually landed, and drove off like 22 miles. Electric batteries.
Yeah, and then they recharge them with
solar panels.
Solar panels that come out and have you guys ever seen? It's the movie with Eva.
WALL-E.
WALL-E.
Yes.
Yeah, and he charges every day and puts that.
It makes the
bing.
window sound.
Yes, makes the window.
Bang.
Bing.
Yeah.
Yeah. So so we have this non-rechargeable battery back in 1830 whatever that was created for this one car, single-use battery. You toss it, you replace it. Really simple battery. No battery management system needed. Really, the battery management system was the dude. They had to come over there, take the battery out, and put the new one in.
That's
right?
correct. Yeah.
But as the batteries get more and more advanced, they then create they've created what's called battery stacks.
Correct.
Can you explain a little bit more about what a battery stack is?
So a battery stack is made of multiple battery modules, which comprises of different battery cells. At the moment, different automotive manufacturers are using different kinds of battery cells to sort of build on to create these battery packs. So the battery packs comprises of various modules, which are then further comprises of different battery cells.
Okay. And
battery cells are could be in different shapes. For instance, Tesla, for instance, uses a cylindrical shape, which is sort of batteries that you are used to.
Right.
But there are other companies or other automotive manufacturers that uses pouches as a battery cell, and they can stack those different pouches and to create a huge battery pack.
Is there a difference between the two, and like by way of performance, or like what's the why?
There are pros and cons, because for instance, the cylindrical battery cells, it obviously takes a lot more space, but they are a lot more robust, whereas battery pouches are easily stackable, but then they don't provide the same sort of efficiency as a cylindrical, or they're not as robust. So there are different pros and cons, and there are different ways that you would require to sort of test them. And for a BMS, for instance, that's the sort of challenges that it will be resolving by providing the state of health of the whole battery pack, or the state of charge, or the state of function.
Really what I'm getting out of this is, various manufacturers create various types of battery packs or battery stacks. So as the battery stacks are created and then have more complexities, then that requires some kind of battery management system to help manage the battery stacks. So what is a battery management system? What is its purpose? What does it do? But even maybe before we even get into that, I think we need to talk about, let's pretend like we don't have anything to control the batteries when it's in the car, right? And we're talking about lithium ion batteries.
Yeah.
Right. And
there's something to like turn them on and off to the motor. Yeah.
What happens when nothing's there to control it?
If there is no BMS and you just charge the battery and discharge the battery, lithium-ion cells will start to degrade. So the life of the battery will start to degrade by roughly 30% if you overcharge it, and it can happen as within a couple of charging and discharging cycles, as well as they can easily go over temperatures. The battery stack can get on fire. And it can have safety implications. So BMS in an EV car plays a very vital role for the safety, for the longevity of the battery stack.
Right.
Interesting. So we're talking about safety
Yes.
of the passenger, safety of everybody else on the road, safety of the car. I mean, just it is a safety concern. And so we want to make sure that the battery management system is working properly.
That's correct. And the battery management systems, they are designed as an ASIC, which is a chip designed specifically to sort of control and monitor the health of the battery. Whether it's temperatures, voltages, currents, to ensure that the battery system within, or the battery pack within the car is working to the best of its capabilities, and it's informing or sending all this data to the ECU to make those decisions.
Gotcha. Okay. So what I'm hearing you say is a properly working BMS can basically save lives.
That's correct. And it can provide a really good alternative, but it is already providing a really good alternative for in the automotive industry.
Yeah, it could also save you a lot of money because I mean, even if the battery doesn't go, nuclear worst case scenario,
Right, okay.
The BMS greatly extends the life of the battery, and I think what was it like Tesla replacing the battery $22,000. So if you can extend that, you want to extend that battery life for as long as you can.
Right, and the battery management system basically regulates the charge so that it doesn't charge it all the way. You were saying, but I can't remember if it was you or you, the optimal charging is between 5% and 95%. Like you don't want to drain it, and you don't want to charge it up to 100%.
That
so the
is
battery
correct.
management system takes care of that for you.
That is correct. If you think
Why?
about this, a battery cell there's anode and cathode, and there's electrolyte in the middle. And what's happening is when you charge it, ions go one way. When you discharge it, it goes the other way. And the best way to sort of keep the battery as healthy as possible for as long as possible, to make sure you don't charge it fully, so all the ions don't go, you don't
One way
fully
or the
charge it
other.
or the other, and it always
Interesting.
stays. And that is how you can actually maintain the longevity of the battery life.
Yeah.
Isn't there a warning that comes up on your Tesla that says, hey, if you charge this thing 100%?
By default, it doesn't let you charge to 100%. It does say that by default, when I bought the car, it says it goes up to 90%. And if I want to increase it, it's up to me, but it will then affect the health of the battery in future. And when I'm driving and you can see if only like 60 miles left on the range, it comes up with a message as well. Well, you go and get it charged now, because if you leave it overnight, chances are the battery will start to go degrade, because then it'll get cooler, and with less state of charge, it can sort of affect the health of the battery.
As the BMS is being used to take on more and more responsibility, it's getting smarter and smarter and smarter. I'm guessing that the test systems around it, right, the ones that come in and test the BMS to make sure it's working properly, need to be more and more complex too.
That is correct. At the moment, if you think about it, the range on different electric cars that are coming out, every year, you see the range is getting extended to a degree. You're seeing the cars are getting more compact, the cars are getting lighter weight. So there's a constant research going on in the advancement of batteries, how to get the best composition out in terms of the power, in terms of the health of the battery, in terms of the density of charge and discharge that a battery stack can hold. So the BMS will also need to evolve. The principles may stay the same, because you will be monitoring the current, the voltages, the temperatures, but how you will be monitoring it, what sort of accuracy that you would need, what sort of scalability do you need in terms of, for instance, today I have a battery pack with, let's say, 96 cells. Tomorrow it could be 120 cells, and if it's Tesla, it could be 7,100 cells, which is crazy. So yes, I can constantly see there's an advancement in the battery technology, and one of the biggest concerns is if you are designing a test system today, what sort of things you will be taking into account in terms of BMS technology. You will be designing things in terms of making sure the obsolescence is taken into account.
Management, yep.
Making sure it will be able to evolve the new BMS systems that will come out in future. It'll be able to test those. So it is an interesting design challenge.
I think it's important to note that building a BMS tester on a platform that can grow with the technology is important. And I think that, am I wrong in assuming that PXI is probably where that's going, or it has been?
PXI has always been renowned for its modularity and its scalability.
Right.
Choosing a system now with PXI in mind, and you know that there is a huge standard behind it. There are lots of companies sort of investing into it. That it's a safe bet. And if you are designing a test system today, that will be the approach to take. Yeah. You won't be bound by any of the standard issues. Right. In terms of sort of companies who have created their own turnkey solutions. Right. If they go bust, or if any of the components go obsolete, it could be a huge problem. So sticking to industry standards would be the way forward.
I know that you had mentioned something about your battery simulators, the PXI-based battery simulators, also fault insertion. Can you explain to me how the battery simulator, the fault insertions, and what the purpose of all of that is?
Yes. So if I am a BMS manufacturer, whether I'm at the R&D stage, whether I'm designing the new or the next generation of BMS, or I'm on end-of-line testing, the sort of things I'll be testing it, if I've got how my BMS going to respond to different situations. So for instance, what our card is actually doing, a battery simulator, it will let you set different channels, different voltages to simulate, for instance, lithium-ion battery. Right. You can set all the channels individually, and it also has measurement capabilities. So when you so what you can actually do as a BMS manufacturer is sort of connect that to a battery simulator and be able to monitor and see how your BMS is working. For instance, if you can actually use one of the channels, which you call a battery cell, and increase the voltage and see how it will react. You can also add a fault insertion into the mix of it and try and break one of the channels and see how your BMS is going to react to it. Also, you can use our resistor card, which is an RTD simulator, and try and increase the resistance and see how over temperature or what will over temperature going to do to the BMS. Right. One of the key things that BMS does in this industry to monitor the health or the state of the batteries is cell balancing, which is if one of the cells is sort of degrading, try to ensure that it doesn't impact to the overall battery pack. So if you start charging the battery pack and individual cells are charging, if one of the cells is charging quicker than the others, then you can end up having a not fully charged battery, because if one of the cell reaches its limit, it will not let you go over the charge limit because it could be a safety risk.
Right.
So what BMS does is it try to bleed that particular cell in terms of try and discharge it while maintaining the charge of the other cells. And that is the beauty of the BMS test system. And those sort of scenarios you can easily simulate using Pickering Battery Simulator.
Yeah, so you're developing the simulator. Why use that instead of actually the battery pack that's going to be going into the car or the whatever EV that it's going to be used with?
I'll give you a real life example. We have an integrator in France that we are working with who are doing end of line testing for their BMSs. They're testing one BMS every 15 seconds, 24/7.
Jeez.
And if you are using a real life battery, I'm sure it'll be a bit of a problem trying to sort of
like you don't want to blow a battery.
no.
Just for the sake of testing the BMS, that would be costly.
I don't think my Tesla can handle that.
Okay. And you said every 15 seconds. I think you've mentioned this before, but there's also I think you said it was 15 seconds per slave. And then there's a master.
That's correct. So the system that they've created, before diving into their test system, I'll talk a bit more about BMS master and BMS slave.
Okay.
So BMS master is responsible for all to monitor the health of the battery by talking to different slaves which are connected to the different battery modules. For instance, in this particular case, a BMS slave was connected to 12 battery cells. It was monitoring their voltages and currents and temperature, and then sending that data back to the BMS master. The reason this process is separate, if you think about it, BMS master has got low voltage signals. For instance, because it's got CAN communication that is sending the data back to the ECU, whereas BMS slave is dealing with doing all the dirty work for you. That's why they always ask you to have BMS packs with galvanic isolation to make sure that the low voltages and the high voltages sort of stay apart, and you don't get any influence. And I think this is where connectors are very, very important in terms of isolation. I think and the sort of system that they've created to test BMS master and BMS slave, they are using a platform agnostic backend, which consists of a number of battery simulators, and in front they connect an ITA. Creating a system like that means that in future, if they've got different needs for their BMS master or BMS slave, they can just simply design a new ITA and away they go.
Right. And changing it up. So that kind of brings me to our next kind of point, which was, and I think you've already covered this, but the applications that drive new BMS systems, so I'm guessing we already kind of touched on that, which was the BMS kind of evolves with the battery stack evolution also, right? You touched on that connectors are a highly important part of a BMS tester. Why?
I would say because firstly, it needs to make sure the isolation between the high and the low voltage stays separate. Because if, for instance, a connector quality isn't great and it can easily influence the data that you're sending from your CAN bus to the ECU, and can easily get influenced by the low quality of the connector.
Right.
So everything within that process needs to be high quality, needs to be spot on, because that's how you can come up with an excellent BMS system.
Yeah. Okay. So what I'm hearing you say is that not just the battery simulator or the fault insertion cards or the PXI chassis or any of that stuff, obviously it needs to be high quality, because we're testing a BMS that then regulates lithium ion batteries that go into a car that you're driving down the road. So it's very important that the BMS is working. Therefore, it's very important that the tester has all the high performance parts to make sure that the BMS is working.
That's correct.
Taylor, what are we doing to make sure that, in making sure that we're providing the highest quality connectors for these types of systems?
Yeah, so our biggest focus on, I think in our designs, is making sure that you have a good quality connection for whatever you're plugging in.
Right.
We were talking about earlier, like the simulators kind of set the nominal voltage for the batteries, and it's comparing that data to what the BMS is measuring to make sure it's good. So we don't want for some reason a bad connection, a bad crimp in our connector to have a little bit of a voltage drop there. So you're detecting, this BMS is not measuring the same voltage as what my simulator is doing or is saying it should be. BMS must be bad, when in reality it's the connector that you're using.
Right.
That's a very interesting point, because the voltage drop that you've just mentioned, in a normal battery cell, if you are near the charge or the discharge points, of a drop of even a 5 millivolt can basically degrade the battery life cycle of the 30%. So it is crucial that the connections are good.
So what I'm hearing you say is that it can be costly to have a bad connector, because what'll happen is they'll think that the BMS is either not working or the battery stacks are not working, when in reality it's just a faulty connector.
Yeah.
A faulty connection. And they'll end up either digging through it and finally realizing it's that, or if they can't track it back to that, then they'll put tons of more time into figuring out the BMS or the battery stack or whatever it is. So that's an issue.
We're getting requests for higher power, higher voltages, higher currents,
and that's the way forward. Because if you think about it, currently there's a lot of research going on in electrification of planes, for instance, and I presume the safety standards will be very different, because if a battery goes down and you are 38,000 feet up,
you're going
up in
down
the air,
too.
It's going to be a bit of it's going to be a bit of a problem.
So let me ask, do you see, obviously voltage and current requirements are going to go up. Do you think, are we going to see really more higher voltage stuff because we can use that more efficiently or higher current?
Higher voltages, I believe we are already seeing it. Initially, we were getting requests for up to 700 volts isolation, and now we are talking about 1,000 volts. And some testers that are coming out, or some requirements that are coming out, is about 1.2 kV. It's likely to go up. That's the only way they will be able to squeeze more as the battery cell composition improves. So will be the charging and discharging voltages, and yeah, that will be the way forward. But that's based on what we are seeing at the moment. In future, we will be seeing new challenges. For instance, solid state batteries. That'll be a whole new game changer, and I mean, to see how we'll be able to sort of keep them going.
Yeah. I'm not super familiar with solid state batteries, but are we just talking about, just higher energy density in those?
Correct. To be honest, I haven't looked much into the solid state batteries either, but that's something that has been discussed a lot. And there are various articles that are coming out. They are talking about charging and discharging particles, or using using various devices. So yeah, that's a fascinating time we live in.
So there's a lot going on in the EV market with just battery stacks, and then the BMS, and then you guys have done wonderful things with battery simulators and fault insertion, and kind of helping drive that forward within the PXI platform.
It's mostly due to the customer-led innovation, as I like to call it, because all we do is just work closely with our customers, get their needs in, and treat that as an engineering problem.
Yes.
And most of our product portfolio, which is over 2,000 products, are all based on different customer applications. And some of the products where we thought, okay, we've designed this. How about if we add this to the particular product? And this strategy has worked great for us.
And I think that's why MacPanel loves working with Pickering to that extent, is because we are a customer-driven company also.
Absolutely.
We design, we manufacture everything based on customer need, customer want, and then also, the ease of use for customer.
Right.
And it's all about that for us.
And we love sharing our knowledge about stuff with our customers, because we're using our product every day to test the stuff that we make. So being able to put in that design insight, it makes their end product better. It makes it, a lot of times it makes it easier for us to build.
Right.
And we can cut down lead times like crazy.
Absolutely. And we've had a number of those occasions just in the last year or two.
Yeah. We won't mention the company name, but there was a series of connector that we just couldn't get, so we'll just make it ourselves.
And that's because thank you for showing the factory floor
today. We went on the tour this morning.
It was absolutely fascinating, and I could easily draw a lot of comparisons between Pickering and MacPanel, because looking at all the design being done in-house, you are in full control over what the product will be like. And when you're talking to the customer, you can then design based on their needs. And we are in a very similar position where we have got a whole design in-house. So when we're talking to the customer and getting their requirements in, we do the exact same thing where we go from designing the PCB to providing the end product. Yeah. Everything is sort of part of it.
Because I think we just want to be an extension of our partners.
We want to be an extension of our partners, and I actually had a podcast last week where I was talking to another group about what we consider partners. And Pickering obviously is one of our partners, but our customer is very much one of our partners. We want to be an extension. We want to be their interconnect extension, right? When they think interconnect, we want them to go, oh, MacPanel might be able to help me. And even if we can't supply product or service, we're still here as a resource to our partners, right? To, like you said, share our knowledge.
Yeah.
Because we have been doing this for since 1957.
Yeah.
Right. So we've been around a while.
And what other company is building hundreds of ITAs a year?
That's right.
I mean, they might build, one or two for their own use.
Right.
Because it is for a test system. You don't, unless you're producing test systems, which is kind of what we're doing.
Yeah.
You're not building a lot of these. We're building hundreds a year.
Yeah.
Especially now with what we're doing. So how to design that so that the usability is there. How to design it so that it's manufacturable. Because there's a lot of designs that come in as like, yeah, the engineer was able to build one of these as a prototype. We got to now figure out how to build 50 of them, and there are a few design changes that I would have made a long time ago to make it easier on us and cut down, like I said, those lead times to get them their stuff faster and probably make it a lot more reliable as well.
Yeah, for sure. Well, it looks like we're out of time, guys. I really appreciate both of y'all's input on this, and I feel like we can go on for another 2, 3, 4 hours.
For sure.
I think we should create a series.
I do too. Maybe next time it can be in England or something. We'll be over there with you.
Yeah, it'll be a pleasure to have you there.
But yeah, so if you're listening and you're in the EV industry and testing various battery management systems and battery stacks, and you want to see a little bit more about how MacPanel and Pickering work together to create a solution for the customer that will help them dominate the application, which is what this podcast is all about, is helping the customer dominate the application. In this case, it would be BMS testers. I would highly recommend that you visit this website where you can find more out about how MacPanel and Pickering work together to provide our customers with the best solutions. Thank you for watching.